So to continue our work with graphing quadratic equations, take a look at this function. This function, f of x equals negative quantity x plus 1 squared minus 4, is a quadratic equation, but it's not in the form that we've been used to working in, right? So we've been working with functions that look like f of x equal ax squared plus bx plus c. And this function doesn't look like that. However, this function is in another form, another special form of a quadratic function. And I want to introduce you to that now. This form's called the vertex form. Looks like this. So the vertex form of a quadratic function is f of x equals a times x minus h squared plus k, where hk, so hk is the vertex of the parabola, and that a is the same a as in our other form. It's in our f of x equals ax squared plus bx plus c form. So that's the same a, okay? So take a look at the function we were looking at. And let me go ahead and put that here, this new vertex form. And I'm going to rewrite that new form that we just discussed, vertex form. F of x equals a times x minus h squared plus k. And we've got that form here, okay? And it's that form if you take a look at this negative sign here. That's our a, believe it or not. That means a is negative 1. Okay, so a is negative 1. Now, to find h, and h, again, that's the x-coordinate of the vertex, right? Because taking a look at this, this is called vertex form because you can read the vertex right off of the equation without having to use the vertex formula that we talked about before. So we need to kind of rewrite this. Notice how in the vertex form we have x minus h, and here we have x plus 1. So I'm going to rewrite this. It's going to be f of x. That negative sign becomes a negative 1, just so that you can see. And then this x minus, I'm going to take the opposite here. And so remember, this I had an x plus 1, and I'm rewriting it as x subtract a negative 1, and then I'm taking and I had a minus, and I'm rewriting that as negative 1, and then I have a minus 4, which is supposed to be plus my k, so plus a negative 4. So what does that mean? Well, that means that a is negative 1, h is negative 1, and k is negative 4. So here, a is negative 1, h, put that here, h is negative 1, k is negative 4. So the parabola is going to still open downward because our a is still negative, right? A is negative 1 is negative, so parabola opens downward. So that hasn't changed. But now what's nice, this is what you're going to like, the vertex is that hk, which we just said was h was negative 1 and k is negative 4. So the vertex is negative 1, negative 4. And you didn't have to solve anything. You could read it right off of the vertex form. Okay? So now we can continue our work here. The axis of symmetry has to go through the vertex. Vertical line, so x equals negative 1. And now we're going to find the x-intercepts. Now this is going to look a little interesting, right? So our equation looks like this negative 1 times x plus 1 squared minus 4. And we're setting that to 0. So now we have this equation that we have to solve for their x-intercepts. And you notice that we have quantity squared here. And we saw that earlier in the chapter when we used the square root property. So I'm actually going to use the square root property. So let's see. Let's move the negative 4 over. So we have negative 1 times x plus 1 squared equals positive 4. And then we're going to go ahead and divide both sides by negative 1. And that's going to give us x plus 1 squared equals negative 4. And now we're going to go ahead and take the square root of both sides, okay? So we're using the square root property. Square root property. So we take the square root of both sides. This is x plus 1. And then over here we do plus or minus square root of negative 4. Okay, so what do you remember about the square root of a negative number like this? Well, this is not real. Not a real number. Okay, so what does that mean? Well, that means that this parabola does not cross the x-axis. There are no x-intercepts. Okay, so again, we got that negative under the radical. No real solutions to this equation, which means there are no x-intercepts in this parabola. So when we go to graph that, we're going to see what that looks like. Okay, y-intercept. So set x equal to 0. So we have f of 0. So let's see. 0 plus 1 squared minus 4. So we got what here? We have a negative 1 minus 4, so negative 5. So our y-intercept is 0, negative 5. So we don't have x-intercepts, but we do have a y-intercept. And then let's calculate here f of negative 3. So negative 3 in for our x. And so here we get what? Negative 2 squared. And this is a negative 4. So negative 4 minus 4, which is negative 8. So we have the point negative 3, negative 8. Okay, let's graph this. So here you see I've gone ahead and graphed our vertex and our points. And do you see now why this parabola does not cross the x-axis? See why we got no x-intercepts? We've got a downward facing parabola. So the highest point is the vertex, but the vertex is down, clear down here. So this parabola is never going to turn around and come back up to go back up to the x-axis. So there are no x-intercepts. So talk about the domain and range here. Well, domain, all real numbers. Again, right? All quadratic functions are like this, right? They have domain of all real numbers, all are parabolas that are functions. And then the range, well, we've got that the highest, the maximum, we've got a maximum here at the vertex. So our highest value of y, or our largest value of y, is that negative 4. So that's going to go on the right-hand side of our interval notation. And then, of course, we've got these arrows going down. So our y values get very small, very negative. So that's the range for this parabola.